Okay, here we are. I'll talk to you again about heat exchangers, and this time I'm discussing tubular bundle heat exchangers. Let's say that shell and tube heat exchangers are, in a manner of speaking, the history of heat exchange, in the sense that they were among the first to be utilized in diverse cooling applications, whether industrial or conditioning. There exist different types of them. They can be categorized as straight tube bundle heat exchangers, brushable, crown or removable, U-tube bundle, multi-pass, single pass, or floating head heat exchangers. Let's assume the typology is highly varied. In some pictures, you can observe the types I have listed, advantages and disadvantages of various solutions, and when they are used. Let's start with the ones we use the most, which are the straight tube brushable heat exchangers. The word itself, let's say, reveals its construction. They are exchangers, where the two heads can be disassembled and the tubes inside which the fluid flows can be seen. These are straight tubes, so they pass from one head to the other and can be cleaned, brushed with a simple brush. Clearly, the diameter of these tubes depends on the type of fluid that needs to pass through the heat exchange. Now, I don't want to go into the details of the design, which may require more detailed explanations. Simply put, by looking at the shape, it is intuitive that I can disassemble the two heads of the exchanger, enter with a brush, and clean the tubes tube by tube, and remove any dirt, clean them from any dirt that accumulates. What's going on? On the outside, so in the mantle, a typical heat exchanger is welded. The tube bundle can't be removed, so I allow the clean fluid to flow through the mantle. They are exchangers that are used, for example, in the cogeneration sector as recoverers on the exhaust fumes of engines. I pass fumes through pipes, clean them in biogas for biogas dehumidification. I pass biogas through pipes. Outside there is glycolated water, which is therefore clean. In the pipes, if my biogas releases impurities, I can clean them. Used for hot water production with steam. In cloak, steam passes. Water flows, gets heated in pipes, comes out in another heated area. What are their limits? The limits related to their length. If I need a long thermal scheme with very long thermal jumps, I have to put multiple exchangers in series because I can't do series passes, or it's a little more complicated. It is feasible, but the construction of the headers gets complex. The other common type is hair or tubular bundle exchangers with a removable U-tube. In this case, I have a tubular bundle, as you can see from the image, which is made up of many U-shaped fork tubes welded to a single header. In this case, the cleanable part is the mantle's outer part, as the tubular bundle can usually be extracted. Obviously, I can't clean the pipes, because if the pipes reach the bottom and make a curve and come back, it's clear that I can't clean the curve with the brush. Dirty fluid tends to be utilized on the mantle side. Even though, I will show you this photo, you can see that when the number of tubes is so high and their construction is so dense that cleaning becomes nearly impossible, or at the very least, highly complex. From this perspective, let's assume added difficulty. In this case, I have a better thermal length, meaning that when examining the diagram of a cleanable straight tube bundle heat exchanger, I can determine the thermal length of the pipes is the plate-to-plate length. In a tube bundle heat exchanger, this length doubles as the fluid can enter from one side and exit from the other, resulting in 4 meters of piping within a 2-meter length. At a construction level, as for materials, you can use a little bit of everything, from stainless steel to copper to iron. It depends on the fluids we treat, the process, the temperatures. Here we enter another big topic, discussing the construction materials of the Duvia belt exchangers. I hope I have been clear and I hope it is interesting. If you want clarification, write.